Again, thanks everyone for attending. This is a webinar for overcoming the challenges of ECAD and MCAD integration in wiring harness design. I'm Andy Schaefers, an application engineer at Maya, and I'll be the moderator today. Next slide, please, Brian. I'll introduce both of our presenters today. Brian Kenyon is with Maya. He started his career in 2012 at BorgWarner Morse Systems, working on variable cam timing systems for various automotive OEMs after graduating from Alfred State College. During his career at BorgWarner, he received multiple as well as an innovation award. And in 2022, Brian joined Maya HTT as a CAD/CAM engineer, where one of his first objectives was to demonstrate NX and Capital Essentials connectivity. Greg Arnault's career in electronics began in the 1990s with Hewlett-Packard in Barcelona, Spain. From 1995, he held various product management and global business development roles in the inkjet commercial division before leaving in 2004 to found a wireless startup developing social proximity applications for Facebook. From there, he went on to run the US operations of Green Power Monitor, a leading solar monitoring company. In February 2020, Greg joined the product management team at Ultrasoft, which was acquired by Siemens in October 2020. In June 2022, he joined the Siemens NX team as a product marketing manager. Next slide, please, Brian. Thank you. So at Maya HTT, we help organizations with their digital transformation journey. Siemens has recognized us as a top global partner in 2022, but we're not just a consulting and system integrator. We also develop software with over 30 modules authored for Siemens used by millions worldwide. 75% of Mayans are scientists or engineers with hands-on experience in nearly every industry. Whether an organization is looking to better design, simulate, manufacture, or optimize operations, Maya HTT combined engineering, software development, and AI expertise uniquely positions us to move you from concept to completion and beyond. You'll see me reappear here with some poll questions later, but for now, I'm turning this over to Brian, who will introduce our topics for today.
Awesome. Thank you, Andy, for the introduction. As Andy mentioned, my name is Brian, and I just quickly want to go over the agenda. Greg will start off on part 2 for why is ECAD, MCAD integration important, as well as give a little information on NX electrical routing and Capital Essentials. Towards the end of part 2, I will take over to discuss why integration is important using NX and Capital Essentials as my examples. Part 3, I will cover the process flow with some slides and demonstrations using NX and Capital Essentials. And finally, Greg will wrap up the presentation by noting the benefits we will see in this presentation. There will be time at the end for question and answers, so don't forget to submit your questions during the presentation, and Andy will relay them to Greg and myself. And with that, I will hand it over to Greg.
Thank you, Brian. Okay, beginning with this slide title here, why is ECAD and MCAD integration important? Now, if you can suspend disbelief for a second here, just imagine, take a moment to imagine a scenario. You're an engineer responsible for working on one of the harness designs in this truck here, and after very many months of hard work, it goes into production, it's now on the road, and you're probably feeling pretty good, huh? Well, let's say a few months later, these trucks are all recalled because of an issue that can be traced back to the harness design you were responsible for. You're maybe not feeling quite so great anymore. This is obviously a bad situation for the individual engineers involved and responsible, but also pretty serious for the company as a whole when we take into account the financial repercussions, the time it'll take to resolve the issue, and the damage to the brand image. This is approaching what you might consider a worst case scenario that highlights the importance of getting your designs right first time. Given the recognized industry trend that electrical content is consistently increasing and becoming more complex, there's more necessity for integration than ever before. not implementing ECAD, MCAD integration could cause three effects. So firstly, you can increase your development time due to the overhead of manually updating the ECAD or MCAD environment during design iterations. And this increased design time can cause missed project timelines. And secondly, it increases the chances of introducing error. When updating manually, it's easy for design inputs to be overlooked. For example, a harness bundle size may not be updated in the MCAD domain following an update to the ECAD data. And this could result in the harness getting too close to comfort to an object that would cause a thermal or abrasion concern. And finally, increased cost. The time spent on a design can increase the cost and overhead from design start to production. Additionally, when risk increases the potential for errors to make it into production, when risk increases the potential for errors to make it into production, it increases as well. Design failures after launch are a worst case scenario in dollar terms, especially if they necessitate a change in the manufacturing process like tooling. In this talk today, we will address these issues using automation, collaboration, and verification with the use of Siemens tools such as Capital Essentials and NX. The overall goal is to solidify the effectiveness of your design processes while minimizing risk to avoid the types of worst-case scenario like the one we just saw there. Siemens Digital Industry Software offers a multidisciplinary approach to engineering lifecycle management that leverages integrated requirements management, secure supplier collaboration, and a single harmonized design, verification, and testing environment across multiple engineering platforms. It allows you to find issues as early as possible in the design cycle of the system while providing industry-leading performance and platform scalability. And now, up here on the screen, this is what Siegmund Haas, the then CIO of Daimler, had to say, is that 80% of product innovation and differentiation is now electrical, electronics, and software. This is especially true in consumer automotive, as the drive toward autonomy is turning cars into literally supercomputers on wheels. With the increase in importance of electronics comes increased importance in the integration between electronics and other systems. Also in this engineering.com survey we see here, 71% in total of designers responded that the value of electrical systems in their products was increasing moderately or significantly. So even taking systems as a whole, the importance and contribution of electronics within them is steadily growing. I'd like to highlight here three trends driving electromechanical complexity. The first trend is the electrification of passenger transport, or the growth of EVs. Now, according to Forbes, EV sales grew in the US by 32% yearly between 2012 and 2016. And the forecast is that EVs will make up 65% of light vehicle sales by 2050. In Europe, the transition to electric cars is something which is enshrined in law. It's the subject of regulation, although recently some groups have sought to water down that regulation. The second and third trends here go together somewhat. Cars will become eventually more and more autonomous, and such autonomy will entail more connectedness. They will need considerable connectivity in order to self-drive. The content and complexity of electrical and electronic systems is experiencing another step change due to this autonomy. The inclusion of 30 or more new sensors to enable the autonomous vehicle to see, and significant new processing power to interpret all of that new sense data adds a considerable amount of electrical and electronic content to a base vehicle. GM found that a self-driving version of the Cruise had 40% more hardware than a human-driven counterpart. The added content creates weight, packaging, and complexity management challenges. Furthermore, a level 4 or greater autonomous vehicle, that's one that can pretty much drive itself, will need to consume gigabits of data per second in order to operate successfully, safely. Intel CEO has estimated that these vehicles will generate 40 terabytes of data for every 8 hours of driving. And what will all this connectedness be needed for? Well, maps are just one example of the incoming data a car will need. And these maps won't be a one-time Google Map download as you might do today. They will have to be extremely detailed and timely, down to the nearest inch. They will be used for lane control and road hazards, among other things, so they will need to be continuously updated. So today's passenger, recreational, and commercial vehicles are no longer just electromechanical products. Modern vehicles come equipped with an array of electronic features and components. These include everything from passenger comfort features like heated seats, air conditioning, and in-vehicle infotainment systems to limited automation and advanced driver assistance systems. In addition, a network of ECUs, electronic control units, now assist essential vehicle functions such as braking, steering, and throttle control. In today's automotive market, the electronics are coming to represent most of the value of a vehicle. So the increase in electrical and electronic features in modern vehicles places more emphasis than ever before on the wiring harness, which transmits power and signals between actuators, sensors, and ECUs. Indeed, we're going to be talking quite a lot about wiring harnesses today and the art of wiring harnesses. And so increased demand for highly automated and electrically propelled cars directly translates to a growing wire harness manufacturing industry. With growth comes fresh challenges and new pressures on the industry. To support the greater number of electrical and electronic systems, some of which are very sophisticated, wiring harnesses are becoming increasingly complex.
Okay, here's our first poll. If you could just quickly check on the system you're using currently for electrical routing, or if it's not listed, just choose other. Well, Brian, the results are coming in. It looks like it's around 60% NX.
Okay,
And
I'll go ahead.
few people using SolidWorks and a number that are not applicable. So looks like mostly NX users here. Let's continue, Brian.
Okay.
That's good. We seem to be talking to some of the right people here. NX is really at the heart of the digital twin for mechanical engineering. NX is used to build the core of the digital twin, that first 3D model, all the way through from requirements to product design, electrical and electronics, tooling, all the way to the factory floor. But the real advantage is to be able to tie this into the rest of the Siemens Accelerator portfolio and take advantage of the collaboration capabilities of NX across disciplines, especially those of ECAD, as we'll see today. So yeah, I'll take a couple of seconds to kind of explain the market success of NX. I just saw some figures today, actually, kind of putting the MCRAD growth down potentially for the design segment at about 3%. And I know that Siemens is growing way faster than that. So what is behind this market success of NX? It's not just the product alone, it's also the comprehensive suite of design products that Siemens provides to complement it. So NX, it lets you take your innovation to the next level, removing those technology barriers you may encounter in other places. For example, deployability. With NX, you don't have to wait to take advantage of the latest advancements in CAD. NX is being deployed at the largest engineering enterprises in the world right after its release. And open technology, what we call open technology, is our realistic, pragmatic approach to solving your engineering and design problems. Siemens Digital Industries does supply a complete suite of software to address the needs of the enterprise, but we do realize that you may want to bring in another software solution. With our open technology paradigm, we have the ability to make this work in your enterprise. Data preservation, finally, is a hallmark of NX. NX will never force you to leave your data behind to move on to the next release. We have always prided ourselves on the ability to use all of the data you and we have created, no matter the platform of the past release. Okay, NX routing harness provides all the tools needed to route an electrical wiring harness consisting of bundles of wires in a product assembly. It has the ability to specify typical mechanical parts and supporting equipment, such as connectors. The software can also import the wiring characteristics for connections between electrical devices. NX routing harness can automatically traverse paths which have been routed between devices and assign the wire descriptions to the path segments as specified in the connection list. The wire descriptions are used to compute bundle diameters and to create solid bundle models. Actual wire lengths and diameters may be automatically added to the connection list for feedback to upstream ECAD applications or downstream to manufacturing applications. NX routing harness also identifies minimum bend radius violations and produces design and manufacturing documentation, such as form board drawings. NX routing harness does more than just flatten a harness. It generates a full assembly with all electrical connectivity information intact. The result is identical to the 3D assembly, but is laid out on a single plate while maintaining the relative position of each connector to the bundle as the harness is flattened. Now, here are some of the principal benefits. I won't go into all of them, just to explain first-time quality a bit. That means that with our inbuilt concurrent design rule checking between engineering domains, you have the ability to get products right first time. In many organizations, electrical engineering in low to medium complexity products is still, surprisingly, it's still largely drawing or Excel based. Excel as in the spreadsheet. Engineers manually create electrical schematics, harness drawings, consolidated bills of materials, that is BOMs and the like. Non-specialized tools such as AutoCAD, Excel, and Visio are often used, supporting manual processes but delivering little to no intelligence. These specialized tools that do exist lack the dedicated data model and functionality needed for true electrical design that have usually been developed for dedicated applications. This situation is no longer sustainable. Electrical distribution systems have become more complex so that the wiring and harness design domains must be digitally integrated. Shorter program development cycles compound the problem. Manufacturers using non-intelligent tools for their design have to rely on a physical prototype of the electrical distribution system in order to validate the harness for production. Since most manufacturers rely on suppliers for their harness systems, a physical prototype is often also used when no digital data exchange is possible. This results in extra delays and costs, as well as labor as well as materials for building the physical prototype that'll probably get scratched once it's been used. Furthermore, and this is interesting if you think about it, electrical engineering cannot be done in isolation. For example, number one, space must be reserved, which is an MCAD task, for electrical components and wire harnesses, defined by ECAD. And then secondly, voltage drop calculations, which is an ECAD task, can't be done without harness bundle lengths, which is itself an MCAD task. And thirdly, consolidated product BOMs, bill of materials, a PLM task, cannot be created without complete wire harness BOMs, which is an ECAD task. So in order to digitize the entire workflow, to allow efficient collaboration between engineering disciplines, NX includes a fully integrated 3D electrical harness routing application that allows users to design and route harnesses in complex assemblies. Built upon the NX routing applications architecture, the electrical routing tools provide electrically smart features and functions to automate the design, modification, and analysis of wire harnesses. The powerful design and manufacturing capabilities available in NX routing enable users to produce a wire harness directly from NX product assembly models. The need to build a physical prototype before producing the wire harnesses is eliminated, significantly reducing product development time. Complexity in electrical distribution systems driven by massive increases in electronic and content and product variation. Complexity will only continue to increase. So electrical design, optimization, verification, and engineering is now best feasible using an integrated data-centric tool delivering substantial automation. Capital Essentials digitizes the electrical domain. Capital Essentials creates the electrical distribution system digital twin upon which unique automation is performed, reducing development costs and cycle times for more functional products. Pardon me. Electrical engineering is inherently multidiscipline. Integrations are needed with adjacent activities such as mechanical design, BOM consolidation, manufacturing operations, and supply chain management. Capital Essentials is built to integrate through data exchange with adjacent domains using industry standard formats. It's an integral part of the Accelerator Share ecosystem and leverages available cloud-enabled ad hoc collaboration, design, publish, and markup capabilities. Capital Essentials provides functionality that helps engineers to deliver rapid, right first time, error-free electrical and harness design. Through automation, analysis, and a plethora of time-saving features, it allows design teams to put their effort where it counts, innovation. One of the powerful benefits of sourcing your software tools from one vendor is that they're guaranteed to work together and grow together. Siemens not only offers Capital Essentials and NX, we are also the company behind Teamcenter. Teamcenter is your proven PLM environment. When integrated with engineering applications, Teamcenter provides an instant access environment to manage information and collaborate. In particular, it maintains items revisions when design changes are requested. As of October 1st, 2021, Capital Essentials is Accelerator Share enabled. That means that in addition to, and independently from, any on-premise Teamcenter integration, the following cloud-based collaboration services are available. So you have secure cloud project data sharing with desktop synchronization, you have messages and task management, and you have view and markup published designs from anywhere. The Accelerator Share brings great value in particular to SMBs for secure ad hoc collaboration with their business partners without having to bear the IT overhead. And from an NX perspective, Teamcenter provides global, integrated, synchronized management of all product data, all process knowledge for all aspects of product development from requirements through to manufacture. It's a single source of product information to support your complete design through manufacturing process. It allows you to have less time spent by designers and partners looking for the right NX data, and it provides live global access to product information and successfully manages your most precious asset, product knowledge. Well, your most precious access may indeed be people, but in this case, we'll say it's product knowledge. And it's over to you, Brian.
All right, yeah, thanks, Greg. Okay, so continuing on in the why is MCAD ECAD integration important? I'm going to go over some of the problems and challenges. So on their own, harness complexity provides significant challenge for each prospective design team. But when the end product is electromechanical in nature, such as electrical wire harnesses, mechanical and electronical designers must account for challenges across both domains. Mechanical designers need to verify the physical space constraints of the harness. Once the wiring is finalized, have I reserved enough space? The electrical designers need to ensure the correct circuit behavior, which requires voltage drop analysis, view sizing calculations that is dependent on real-world wire lengths. How can I get these wire lengths needed? The harness designer needs to reproduce the 3D harness topology in 2D and combine it with the electrical data. If the 2D harness is just a replication of the 3D harness, why should it need to be recreated from scratch? Can I reuse the topology? Or how can I figure out how much overstock material is needed? A design flow incorporating Capital Essentials supports collaboration and concurrent design. Customers can design physical harness in NX while the electrical and harness designs are done within Capital Essentials. The mechanical designer defines the harness geometry and fixtures along and reserves space in the structure. The electrical designer, using Capital Essentials, designs and masters the electrical content for the system by creating the needed wiring diagrams consisting of devices, connectors, and connections, and conducting analysis. The mechanical and electrical disciplines can work independent of each other, but can easily pass data back and forth as it becomes available. The harness designer, using Capital Essentials harness, combines the MCAD and electrical data to fully define the electrical mechanical harness product. Having a better understanding of the impact of electrical and mechanical specification decisions may have on the other domain is critical to the overall design quality. The data exchange that is supported by Capital Essentials NX can save design time and potential for manually induced errors. In Capital Essentials, I'm going to show what the data may look like before performing the exchange. You can see here that there are various schematics that make up the electrical design. Also, we have some of our connectors, our inline connectors, some splices, some conductors, also known as wires, that complete the design. This design has been done with no NCAD input, but it will still need some more information to obtain higher chance of first pass success. On the NX side, you can see the harness part has been created with the appropriate connectors in their respective locations. If I open the Part Navigator tab, you'll notice there's a set of space reservation features. These space reservation features provide a mechanical designer with a pre-check of the space allowed for the harness before it is a concern in scenarios like abrasion or heat. Notice that the electrical component navigator is empty and there are no components assigned, as well as the electrical connection navigator. If I come up to the route list tab and open the create tool, there is always the option to assign the components and create connections using the connection wizard. But because we will bring in the ECAD data, I will not need to perform this task. Additionally, it would be a duplication of work knowing the ECAD data will be used and could open the opportunity to increase errors. For example, the wrong wire stock was used in the connection. Just like we saw in the ECAD domain, this has been done with no electrical information. So,
Okay, here's our next poll, Brian. So for the participants, if you could, just let us know what method you're currently using to share data between MCAD and ECAD. Looks like a 50-50 split here between a wiring harness file or traditional office tools like Excel and text. Oh, and a few people have developed their own custom interface.
okay, so looking at the process flow, using file types like PLM, XML, JSON, and zip file, otherwise known as the extended wiring harness format, data can be exchanged back and forth between the two domains. From Capital Essentials wiring design, the route list can be bridged into NX and the bundle size will be updated based on the Capital Essentials wire stock diameters. Additionally, the newly routed data from NX can be bridged back into Capital Essentials to return wire lengths. For harness design, the topology from NX can be reused to create your 2D layout in Capital Essentials. Additionally, you can send data into Capital Essentials such as protections and supports. You are also allowed to return stock diameters from harness design to NX. Both methods of exchange also allow to send and return splice locations. There are different methods to transfer the data between NX and Capital Essentials. There is file mode, which is typically done with the file types in the previous slide. These files would be typically shared in a company known location. Team Center mediated mode, which is very similar to file mode, but the files are read as data sets in Team Center and the changes are tracked through the PLM. And lastly, NX connected mode data exchange. This enables real-time data import and export, as well as cross-highlighting for ease of use analysis during wiring design. Functionality automatically switches between wiring mode and harness mode exchange as needed in the same application. Any selected objects in NX will be cross-highlighted in your diagram in Capital Essentials and vice versa. For example, selecting a wire in Capital Essentials will cross-highlight the corresponding shortest route path in NX. There are many available objects that allow cross-highlighting, such as devices, wire bundles, connectors, splices, clips, and so on. For these demonstrations, I will be showing connected mode. Now that the wiring design has been defined in Capital Essentials, and in NX we have also routed the harness path through the structure, we can now start the process of exchanging data in connected mode. Connected mode must be established in NX before Capital Essentials, and you must make sure the routing harness application is turned on. Additionally, there are a few wiring preferences that can affect the behavior of connected mode. We won't go through these, but I just want to highlight delete space reservation on route. I'm going to keep that not selected for now. Once everything's set, I can go to route list and connect to Capital. You will get a window saying, do you want to connect to Capital? And we're gonna go ahead and click OK. Inside Capital Essentials, I'm going to show the properties of this wire. Take note that the harness is set to door DR. This is an important attribute as it defines what harness design the objects are associated with. Also, take note of the outside diameter. This value will come into play when creating the harness bundles in NX. If no outside diameter exists, the wire stock you may get an error saying that the bundle sizes may not be able to be updated. Once this is all set, we can establish connected mode in Capital. I'm going to come up to Workflow and click the NX Connect button, and this will tell us it's connected. Once connected mode is established, I will go to the Capital Essentials tab and select my bridge filter. Inside the bridge filter, you will see various harnesses, but for this case, I'm building the door DR. Once again, I'm going to go to the File tool, Export to, and this will automatically export the data to NX. Notice there were 13 connectors, 3 splices, and 33 wires and connections. If I come over to NX, you'll notice that there are some components that need to be assigned. I can just go ahead and auto assign. As you notice, these splices did not get placed, so I'm actually going to quickly place those splices. Because we are in connected mode, there's likely some sort of communication between the ECAD and electrical domains. So the splice locations can always be moved further down in the process. Now that the splices have been placed, we can navigate to the electrical connection navigator and use the auto route tool to automatically route the wires to the component level. The connections have now been routed, but notice there's a design rule violation that appeared on the screen. I can fit the violation into the window to better understand where the violation is located. And we can also display some information about that rule. Having these design rules in place can help make sure that the design is verified in the MCAD domain and assist in catching any potential problems that may have been generated once the ECAD data is brought in. In this example, I'm just going to override the design rule as the violation was not a cause for concern. In the reason for the override, I will just note that there was no issue. Now that that is resolved quickly, I want to show the cross-highlighting capability. If I select the connector in Capital Essentials, you'll notice the connector in NX also gets highlighted. Same goes for wires, and there's the ability to select the in NX and highlight the corresponding objects within Capital Essentials. Now that the MCAD domain is free of violations, I'm going to remove the space reservation as there's no need to keep it in there after the routed data has been created. Back into preferences, I'm just going to check delete space reservation on route. I'm going to quickly unroute the data and then reroute it, and my space reservation has been deleted. This harness design looks good, so now it's time to send some wire lengths back into Capital Essentials. If you look at the wire here, you'll notice the length is 1037. I will use the cross highlight to find what the wire is in Capital Essentials and display the wire properties. In the properties of Capital Essentials, you'll notice that the length is 1220. This needs to be updated from the MCAD data. Once again, in the Files tool, I'm going to select Import From. This will automatically bridge in the data from NX. We can see a similar bridge report to before. And if I come back into the properties of this wire, it is now 1037, which matches the length in NX. As you can see, data can quickly be passed back and forth between the two domains while keeping good engagement between the MCAD and ECAD designers. So for verification in NX, as we saw in the previous demonstration, upon bringing the routed data in, a design rule violation was instigated. Violations are stored within the assembly and will notify the user of problems. If you look at the image on the screen for the bend radius violation, this violation was instigated while the MCAD designer was creating their space reservation. So the error was corrected before the ECAD data was even brought in. If no space reservation was implemented and the routing bundle was large enough to break this bend rule, the violation would still get displayed on the screen and cause the mechanical designer to rethink his routed path. NX is preloaded with extendable design rules to ensure that wire harness follow company design standards. Customers can also add custom design rules. Violations can be reviewed and corrected at any time, as seen. For verification in Capital Essentials, once the wire lengths are brought into the domain, analysis can be used to validate the electrical design. With accurate wire lengths and now present in the design, we know that any simulation and analysis being performed is using the true data to be able to find potential issues like voltage drop along wires. If the analysis identifies an issue, in this case, the wire stock is too small, the stock can be quickly updated and the analysis can be reperformed. Then, using the previous steps for wire transfer, the data would then be exchanged quickly again to see if the increased bundle size in the MCAD domain is a cause for concern. The verification in both domains would continue quickly, as you can see, until both the mechanical and electrical design needs are satisfied. Both MCAD and ECAD data can be combined to update the harness topology and drawing for manufacturing. There is the ability to reuse the 3D data as mentioned before to generate the topology in Capital Essentials. Additionally, you can transfer overstock data like insulation and wraps from NX into Capital Essentials to quickly update the materials needed to fabricate your harness design. Now that the electrical design has been satisfied in Capital Essentials, with the analysis tool, and NX design has been properly routed through the structure, keeping the design rules in mind, we can now start the creation of our harness drawing. In the step not shown, there is an area concern in the harness design, and the mechanical designer has added overstock to the design. With the 3D harness created in NX, we can reuse this information to create the drawing in Capital Essentials. Here, I'll come to the project window, right-click, select New Harness Design. I'm going to keep the default name, but assign a part number to the design and also a quick description. For the harness group, I'm going to put in the value we saw earlier for what harness objects we want to filter to and use for the harness design. I'm going to check the full length box, so the harness will be full scale. There are some other options in here that can be selected when creating the harness design, like seal harness and plug connectors, and also insulate harness. Once I select OK, the harness design and diagram is automatically added to the project we are working on, and a blank drawing page was created. Because I selected full scale for this harness, I'm just going to quickly go ahead and update this border to a larger size. With connected mode still established, we can start the exchange process. Before I bridge the data, I just want to mention that the electrical connections are actually not necessary and considered optional when bringing in the topology into Capital Essentials. But since we've already routed them and gotten our bundles, I'm just going to leave them in there for the exchange. Like the wire bridge before, we will go to import from. This time, because we are in the Capital Essentials harness design, we will get an import window for the harness design. Inside of this window, there are a few import types, like replace wires multi-core, replace all, and update all. I'm creating a new harness, so I'll use replace all. There's also some flattening methods and some options to display report and view harness. I'm going to keep the view for harness on for this and go ahead and hit import. Because we had view harness selected, the harness view window will appear. In this window, you will have a few options that we saw in the previous import window, such as the flattening method. There are also some options to flip the harness and rotate it. As you can see in the bridge report, everything was imported successfully with no errors or warnings. Now that our data is inside of Capital Essentials Harness Designer, I'm going to show that it is still possible to do the cross highlighting between domains. As you can see here, I can still connect the different connectors. I'm not happy with this topology, so I will spend a few minutes moving some branches around to clean it up. After a few minutes of cleaning up, it's time to start sharing some more information between the domains. Looking at the installations that came with the MCAD harness data, I'm going to look at the properties of this installation here. The length is 271. Back in NX, it's been decided that the insulation needs to move from this wire to another bundle. I'm going to go ahead and do that. And if you notice, the length is 300. It's also decided that the splice location did not look ideal and needs to be moved in the MCAD domain. Over in Capital Essentials, this splice and this insulation are the objects to be updated. Using the file bridge, we can use import from to get the data updated into NX. The import window, instead of using replace all, because our harness is already there and we don't want to overwrite it, I'm just going to say update all. Additionally, I can turn off view harness as I already know what my harness looks like. With all that selected, I can go ahead and click import. Again, the bridge window shows no errors or warnings. If we look at splice 293, we can see that its location has moved. Also, if we come into the installation, we can see that the insulation has been moved. And if I come back into the layer details of this, you'll notice it's still 271. Using the Capital Essentials automation tools, we can quickly update this. I'm going to update the bundle, the insulation lengths, and if you notice, the length is now 300, which matches the NX data. There's also the ability to move splice location inside of Capital Essentials. Using cross highlight, the electrical designer may ask if the splice would be okay to move to this bundle here. The answer was yes, and the splice has been moved. Our next step will be to synchronize the harness diagram with the wiring diagram. To do this, the wiring diagram must be saved and closed, and the harness diagram must be saved as well. Synchronization will allow us to use any of the data in the wiring diagram in our harness diagram as well, such as bundle size. Although NX will calculate the bundle sizes based on the wiring diagram, I'm going to use the automate tool to calculate node and bundle sizes based on the wiring data as the splice was moved in Capital Essentials. So here I'm just going to go back to the automate tool and update the node and bundle size. Looking into this bundle, you'll see that the width is 4.6. Using the filter bridge tool, I will export this harness diagram into Capital Essentials using export to. We can see that the bridge report, there was no errors or warnings. In the electrical connector navigator of NX, I can route the data to the component level. You can see here the splice has moved. And if I come into the properties of that same wire inside of NX and look at the attributes, you'll notice that the OD is 4.6, which matches the Capital Essentials data. That concludes the demonstration for Harness Design Exchange. As shown here, the exchange is quick and can be used to update the design in both domains to produce a manufacturable harness drawing with minimal steps.
Thank you, Brian.
Thank you.
Thank you. That was awesome. And thank you, everyone, for your time today. I hope we've been able to show you that through efficient communication and collaboration using Capital Essentials and NX, design intent can be properly communicated and implemented to help you achieve first-pass success. And how having the right set of tools with built-in interoperability can help you generate the opportunity to innovate better and get to market faster. This pretty much wraps up the presentation for today. I would, just before we go over to the poll, I'd invite you at any time to enter your questions into the dashboard there. If you have any questions there, you can enter them at any time. And now I'm going to hand back to Andy.
Yeah, let's put that last pull up. Thank you, Brian. So are you or your company planning to purchase or upgrade your CAD tools, and over what time frame? You just give us a quick answer. And it's looking like most of you are out a ways in the next 12 months or more. And I suppose that's appropriate for a integration like this, but there are a few of you looking to integrate in the next 6 months or so. Very good. Okay, well, let's continue then. Our next slide just gives you some resources that you can use here on your journey towards improved MCAD, ECAD integration. We're happy to email those to you if that's better for you. Can you go to the next slide, Brian? Here we've got a couple of email addresses for our presenters today. Please feel free to contact them if you would like those resource links from the previous slides. And at this time, we're going to open it up to any questions that you have. Again, please enter those. Is someone trying to comment? Sorry. Okay. And the first question we've got today, I think it might have come from someone who is using the Office tools for integration right now, but it's just a general question of what are the benefits of using the Siemens MCAD and ECAD together. Could one of you guys take that question?
Yeah, I'll be happy to jump in on that one. Hopefully my mic is still working here. Well, you know, sourcing all of your design tools from the same vendor, it has a lot of benefits. They are, of course, guaranteed to work together. And at Siemens, we spend a lot of our time, a significant part of our planning time, ensuring alignment between the different design tools that we have in our portfolio, which also has the added benefit that new enhancements in one tool are available for use in the other. You know, there isn't a lag while other vendors are catching up. And this alignment or combined development helps to ensure compatibility from day one of a new version release, something that can't be achieved when the design tools are coming from different vendors. So, you know, using tools from completely different vendors can prove to be more costly. For each new version of a tool, it would have to be tested and verified independently. You couldn't be sure that it's working with the rest of your suite. And if you're using tools from Siemens, then the testing and verification has been done up front. Additionally, in the context of what we've been talking about today, if you think of using like ECAD and MCAD tools in collaboration, they're essentially, they could be using different vocabularies in each domain. So it's important to be able to communicate between these two different domains. So examples we've seen today of being able to break those communication barriers or get through these barriers is the cross-highlighting and the live communication in the connected mode. All right, thank you. Back to you, Andy.
Yeah, the next question looks like kind of a technical challenge question. You showed connected mode on the same computer, but is it possible to connect machine to machine, by which I think they mean having multiple machines in use for the process?
Andy, I can take that one. So the short answer to this is yes. There is an option to do cross-highlighting remotely or over the network, as I would call it. Siemens recognizes that electrical designers and mechanical designers can reside in different physical locations. So the intent would be to set up connected mode during a meeting and communicate efficiently through key areas of the design using the remote connection.
Okay. And our third question here is, can you also create harness manufacturing drawings in NX?
I'll take that one as well. So yes, if desired, there is the capability to create harness manufacturing drawings inside of NX using the NX form board tool. Automatically, it can create the flattened model of the right wire harness that includes electrical intelligence, such details such as wraps, clips, grommets, and relative to positions of the harness. Manufacturers could actually use the NX form board to basically as a model as a reference for 3D jig design. But the preferred method would be to create the 2D drawing inside of Capital Essentials like shown.
Okay. Brian, our fourth question here is, how many connections are supported by connection mode?
So, okay, yeah, I'll take that one. So for connected mode, for the number of clients that can be supported, it's just one. So you can't have multiple people inside of Capital Essentials pinging the NX, because then the original Capital Essentials user would then be kicked off the local and network connections.
Okay. Next question. How does the NX model change based on data coming in from Capital Essentials?
Okay, so yeah, since in connected mode, everything kind of happens in the background, but only the components in the connection navigator get updated based on the incoming data. So only the electrical content is updates includes like the wires and splices. Additionally, you can kind of go into these file types like PLM, XML, and it'll actually give you kind of I guess a description of what's included in these files.
Great. Okay. Next question. Can this software perform harness analysis such as voltage drop, mass, and cost so that optimization could be performed on each configuration?
Yeah, I can take this one out. So Capital Essentials does offer the option to calculate voltage drop. And with the, I guess the costed BOM, I'm not sure if it optimizes, but when you do import the data from NX, as I kind of showed, it will give you updated, say, lengths for even like overstock. So that could be used to kind of make sure that your costed BOM is at least correct. If you would like, you can email me that question and I can certainly maybe provide a better answer in terms of the mass. But yeah.
Yeah, I think that's fair. It sounds like it's a complex question that might need some follow-up. Okay, currently our last question here is, are Capital Essentials design and Capital Essentials harness different tools?
Yeah, so Capital Essentials Design and Capital Essentials Harness can be purchased individually or as a Capital Essentials electrical bundle, which provides access to both tools with a single executable. So.
I don't believe any other questions are coming in. Please fire one off if you need to. But at this point, we're going to close our presentation. On behalf of our presenters and myself, I'd like to thank you for attending today. And also, I'd like to thank you for including us on your journey to improved MCAD, ECAD integration. Good day, everyone.